College Algebra, Chapter 1, Section 4, Radical Equations, Equations in Quadratic Inform, and Factorable Equations. Objective 1. We want to solve radical equations. Well, what are radical equations? They're equations with a radical sign in them. And therefore, in order to get that, you isolate. This is sort of the two steps in general. Isolate the radical. And then you square both sides. So that's what you're going to do sort of over and over, all you need to do, until you have solved for the variable. You can, because squaring both sides can introduce extraneous solutions, you need to check your solutions once you have squared both sides and you get an answer, because they may not be correct. Squaring both sides, if your final answer were a -2 and you squared both sides, if you're trying to go backwards, so to speak, and take the square root, you'd get x equals plus or minus 2. Because both of those, if you square them, gives you 4. But only one of those really was the true original x value. So sometimes squaring both sides to solve things gives you an extraneous root, because it's looking for the plus and minus part. So we got to check these when we're all done. It's best, I guess, to look at an example. So let me get a new screen. So the square root, 3 minus x plus x squared. If that equals x minus 2. So how do you solve this? Well, you isolate the radical. It's already isolated. You square both sides. Squaring the radical side is pretty easy. You just get rid of the radical. Squaring the right side, though, this is a binomial. This is x minus 2 squared. This is x minus 2 times x minus 2. So it's not, you don't just square the x and square the 2. You've got a middle term in there. This is x squared minus 4x plus 4. So that negative 4x you might have missed if you don't go through either FOIL, that square root procedure, or squaring procedure. Be careful. Subtract x squared from both sides, you get 3 minus x equals a negative 4x plus 4. That's subtracting those two. I'm going to add 4x to this side, so now with that negative x, it's 3x. Subtract 3, and I get a 1. So x is equal to 1/3. So are we done? No. You've got to check it. You don't know if the squaring both sides has introduced this as an extraneous root. So check it. So we've got, down here, I guess, the square root of 3 minus 1/3 plus 1/3 squared. Does that equal 1/3 minus 2? Let's see. This 3 minus 1/3 is really 2 2/3, plus 1/3 squared is really 1/9. And 1/3 minus 2 is a negative 1 2/3, or this is 5/3, right? Negative 5/3. So these have got to be ninths now. So this is 8/3, 2 times 3 plus 2, and this is 1/9. So if this is ninths, multiply by 3, we get 24 ninths plus 1/9. That's underneath the radical. Does that equal the negative 5/3 we found on the other side? Well, the square root of 25/9. Combine these fractions. Negative 5/3. Square root of 25 is 5. Square root of 9 is 3. Not quite the same. That negative gets everything wrong. This is extraneous. The solution set is the empty set, which is either open braces or braces that don't have anything in it, or that's 0 with a slash. Does this make sense? Let's do another example. Sometimes you'll have two radicals. Square root of 3x minus 5 minus the square root of x plus 7. That equals 2. Well, it's important to isolate and square. So in order to isolate, well, let's add this radical, which is negative, to the other side. Square root of 3x minus 5 then equals the square root of x plus 7 plus 2. Now we square both sides. This isolated radical is easy. 3x minus 5. This is a binomial. The shortcut is sort of nice. Square the first, double the product, square the second. Squaring the first is just x plus 7. The product is 2 times the square root of x plus 7. We double that, we get 4 times the square root of x plus 7. Don't forget this middle term. And squaring the 2 is 4. Don't just square the x square root and square the 2. You'll get it wrong. Now we have another radical here still. Let's isolate it. Let's see, the 7 and the 4 together is 11. I'm going to subtract 11 and I'll get a negative 16 over here. Here's an x that I'm going to subtract and I'll have 2x here. That equals the 4 times the square root of x plus 7. Now when I say isolate, I should really say isolate the term that has the radical, because this 4 is not going to be a problem when you square. It'll just become 16. But this is a binomial. Square the first, 4x squared, double the product. It's a negative, see, this is 2 times 16 is 32, but you double it, 64x. Square the negative 16, well, it's positive because it's squared, 256. Square the 4, you get 16. Square the square root, just x plus 7. Now, let's see here. We need to get this. This is 16x. And what is 7 times 16? 42. 7 and 4 is 11. 112. So, this is now 16x plus 112. Subtract the 16x. You get 4x squared. Subtracting 16 really adds it. So you get 70, 80. Positive 80x. I'm sorry, it should be negative. Subtracting 16x. And you're going to subtract 112, which gives us 144 equals 0. Now that you've gotten rid of all your radicals, we can use what we know about quadratics to solve this. First of all, let's factor out a 4 from everybody. That will not be part of your answer then, because 4 can never equal 0. Divide 80 by 4, you get 20. And divide 144 by 4, it goes 3 times, and then 6 times. So this is 36 equals 0. See if we can factor this. I'm going to move this way up to the top. Don't worry about the 4. It'll never be 0, so we can really forget about that. X times x gives you x squared. The factors of 36 that add up to 20. Well, 6 times 6 adds up to 12. 4 times 9 adds up to 13. Shoot. See, 36 is 3 times 12. No, that's 15. 2 times 18. Oh. So a negative 2, negative 18 equals 0. So x minus 2 equals 0. So x equals 2. X minus 18 equals 0. X equals 18. Are they both good? Well, I'm going to run out of room here, but when you check them, you'll find that 18 does check, but 2 does not. And that's the easier one to put in there just to see. So let's plug it in there. Let me change color so it'll be easier to see this. So I'm going to put a 2 in, and I'm going to get the square root, way down here at the bottom. 2 times 3 is 6, minus 5 is 1. I guess I don't need a big square root there. 2 goes in here. 2 plus 7 is 9. Does that equal 2? So you get 1 minus 3. Does that equal 2? No, this is a negative 2. Or equals positive 2. So that's why the 2 does not work. But you plug in an 18 and you'll get it to work. So your solution Z is just 18. Put it right here in the middle. Boy, that sure filled that thing up. So, how about solving equations quadratic in form? It's sort of what we did here. Well, we'll go to our example. This is objective 2. Solve equations quadratic in form. So in other words, we want a times something squared plus b times that same something that was squared over here plus c equals 0. And if we can write that, then we're going to do something called u sub. We're going to use a u to substitute for this box. Let me show you what I mean. Suppose you have 2x plus 5 squared minus 2x plus 5 minus 6 equals 0. Well, you think of this 2x plus 5 in that box, and we've got a quadratic. Something squared minus that same something. So I'm going to let u equal 2x plus 5. That's the u sub, because now I'm going to put in a u wherever I see a 2x plus 5. So this is u squared minus u minus 6 equals 0. I'm going to solve this quadratic for u. So you can make all kinds of jokes. This can be factored. U times u is u squared. The factors of 6 subtract and give me negative 1. Well, 3 and 2 will give me a 1. If I make that a negative 3 and a positive 2, that'll be the negative 1. So u minus 3 is 0. U plus 2 is 0. So u is either 3 or u is negative 2. That's what u is. Now we go back up here and change it back into terms of x. So if I have 3 equals 2x plus 5, subtract the 5, you get a negative 2 equals 2x. Divide by 2, you get a negative 1 equals x. Plug in the negative 2. A negative 2 equals 2x plus 5. Subtract 5 from both sides, you get a negative 7 equals 2x. Divide both sides by 2, and negative 7 halves equals x. And those are your two answers, negative 1, negative 7 halves. So you make it an easier problem by doing this u substitution, or u sub. Let's try another one. X to the 1/2 minus 3x to the 1/4 plus 2 equals 0. Now when you see these trinomials like that, you should say, gosh, can I make this into something squared? Can I make x to the 1/2 equal a u squared? What do I have to let u be? Well, remember, this middle term sometimes can give it away. That box is the only thing here. So the box is x to the 1/4. Does that work? X to the 1/2. Does that equal x to the 1/4 squared? Well, remember, when you take a power to a power, you multiply the powers. This becomes 2/4 or 1/2. So yes, it works. This is what you're probably thinking. So I'm going to let u equal x to the 1/4. Then I get u squared, just show that over here, negative 3u plus 2 equals 0. An easier problem. Can I factor this? The factors of 2 that add up to 3? 2 and 1. U times u, 2 and 1, signs are the same, both negative. So u equals 2, or u equals 1. But we don't want u, so 2 equals x to the 1/4, or 1 equals x to the 1/4. In order to solve for x, you take both sides to the 4th power. 2 to the 4th equals x. 2 to the 4th is 16. Take both sides to the 4th power. 1 to the 4th is pretty easy. It's just 1. Now, do I have to check these like I was doing before? No, because you didn't square both sides. You took both sides to the 4th power. Wouldn't hurt to check this, though, using 16. Square root of 16, that's what this is. 16 to the 1/2 minus 3 times 16 to the 1/4 plus 2. Does that equal 0? Square root of 16 is 4. Now, the 4th root of 16 is 2. Because 2 times 2 times 2 times 2 plus 2 equals 0. Here, 4 minus 6 plus 2 equals 0. Yes, 4 and 2 is 6, negative 6. You can plug in the 1. 1 to the 1/2 minus 3, 1 to the 1/4 plus 2 equals 0. Well, any 1 to any power is 1. So this is 1 minus 3 plus 2. Does that equal 0? Yes. Okay, so my solution set in roster notation, 16 and 1. Order doesn't matter. Objective 3. Solve equations by factoring. It's more than just quadratics in this case. Okay, let's suppose 3x cubed plus 12x. And that equals 5x squared plus 20. Well, factoring really means we got to get things equal to 0. So let's write this in decreasing powers of x. 3x cubed. I'm going to bring this 5x over as a negative 5x squared plus 12x. Subtract the 20 from both sides to get 0. Let's group these first two and the second two. Don't know if that'll work, but I think it will. I can pull out an x squared. And I get 3x minus 5. Here I can pull out, see, I can divide both by 4. I think that's the biggest. It also gives me 3x minus 5, which is what I want. Factor this common factor, the 3x minus 5 from both, and I'm left with x squared plus 4. So 3x minus 5 equals 0. 3x equals 5. X equals 5/3. X squared plus 4 equals 0. X squared equals negative 4. That's a negative. X equals plus or minus the square root of a negative 4, which is plus or minus, pull out your I, and the square root of 4 is 2, so it's plus or minus 2i. Does this make sense? Let's see. So because it's a cubic equation, you should expect 3 answers. They are the 5/3, the 2i, and the negative 2i. So you might get some complex solutions that way. That should be all for this section. I think you should be able to do the problems well enough. We'll see you in the next section.